Hello student, this is Sarwar AD here. Today we are going to discuss about further phylogenetic constellation of this class, the Pyxes or the fishes. Here, two series of the evolutionary events, radiation of the teleost fish and evolution of the terrestrialism. In detail, we will mainly focus on these 2 points, radiation of teleost fish into the organism which lead their life on land, and further the evolution of the terrestrialism. This is the same thing, but we can say that the organism develop various type of structure in their body which were the need of that time to sustain life on the land. Terrestrialism, about the terrestrial life you have learned a lot, but terrestrialism, this is a condition where any organism develop various type of bodily structure which are required to spend a life on land. And here name of an organism is written Tetrapodomorpha. Tetrapodomorpha was the organism that was containing they were containing 4 limbs in their body. That's why they are said Tetrapodomorpha, and they are considered as the ancestor of the extinct amphibians, not the extant amphibians. Mean all offspring or all the genera belonging to ancestor Tetrapodomorpha, they had been also extinct. Next are the Osteolapiformes or the Sarcopterygian. These were the organisms belonging to the Sarcopterygian, or they were having characteristic like Sarcopterygians. Common feature with the amphibians, because when we are discussing about the phylogenetic constellation of fishes, surely we will move towards the evolution of amphibians and other higher chordates like reptiles and birds and finally mammals. But most commonly we will focus on evolution of amphibians, and they possess jaw, teeth, vertebrae and limbs. Here, this is a representative animal from the past that is generally said as fishapod. Mean these organisms were like the fish. They were also having feet-like structure in their body. They had the scale on their body. They had the fins and gills, and dorso-ventrally compressed and the widened skull. Skull was very compressed and dorso-ventrally widened. Lack opercular spot and dorsal and anal fins. They were not having dorsal and anal fins, and also the opercular spot was not present. Pectoral gill and the freely movable neck. This was major character, you can say, by that time fishes develop movement of neck. This is very easily can be seen in higher chordate now. Here these are the fossil record of fishapod. Here you can see the head-like structure. They were also possessing fin which was acting as feet on the land, and they were the organism. They just try to forage in the water near shoreline or near edges of the water bodies for prey. The fishapod, this 375 million year old fossil, help us to understand the transition between Sarcopterygian fish and tetrapods. This is the lineage between the Sarcopterygian fishes and the tetrapod. Its tetrapod-like feature were probably used in foraging the water's edge for prey. Mean they were trying to forage on the shoreline or on the edges of the water body, because they were in a state to capture various type of the small prey. These are different limb structure and various bone structure of different organisms. The fossil record provide clear evidence of the evolution of the tetrapod limbs. A are the Sarcopterygians. Figure A mainly here. This is the figure A. This figure represent limb structure or limb bone in the Sarcopterygians. However, the limb was the fins, because we have discussed that Sarcopterygians are the low fin fishes. In during the classification or survey of the fishes, we discuss about this. The Sarcopterygian Ceropterus. Here, this is the B structure, and the bone arrangement in the limb are shown for the Sarcopterygian Ceropterus, and the C are the forelimb of the tetrapod Ichthyostega. Acanthostega and Ichthyostega are considered now the most probable ancestor of the extant amphibians or other tetrapods. Forelimb of the tetrapod Acanthostega is shown in and Ichthyostega in D. Here you can easily differentiate between different structure and their length and their variability. And this was all for the adaptation for the terrestrialism. Here it was a brief overview of further phylogenetic consideration that is mentioned in the chapter fishes, but today we will not stop here. We will go ahead to explain all these things, particularly the 2 points I discussed at the start in details in next slide. I will slightly share the next slide with you, but before that I will just discuss about the adaptation in fishes. Like they are also the organism which may be in a state to live in a very extreme condition or the harsh environment, so they have also various type of the adaptation in their body. Here some fishes have remained unchanged for millions of years. Coelacanths. Here some fishes are able to walk on land and can survive for long period of time without water. We are well aware with the lungfishes, and we have been discussing throughout our lecture on the fishes. Few fishes living in water, they may be the top predator. Many fishes function as a top predator in their ecosystem. Here example include great barracuda and arowana. You have also learned about piranha, yes, they are also considered as very dangerous fishes, and they are also considered among the top predators. Many fishes are adapted to survive condition in the deep oceans, like where there is no light. They may have adaptation for this type of the lifestyle, and in the extreme pressure, like angler fishes. Here these are different type of the fishes which have adaptation to survive in extreme condition in the deep oceans. जी ना, उसी चीज़ की जो हमने पहले पढ़ा ना फर्दर फाइलोजेनेटिक कंसिडरेशन, उसी चीज़ को इस लेक्चर में थोड़ा सा और एक्सप्लेन किया गया ताकि आपको, ये आपका बकायदा एक आर्टिकल है ओरिजिन ऑफ टेट्रापोड. Before you start the chapter amphibians, you need to learn about the origin of tetrapods. Tetrapod mean organism having 4 limb in their body. 2 may be considered as the hind limb, and 2 are the forelimb. Origin of tetrapod, these are the objective to describe the evolution of tetrapod. Because it is a separate lecture, this is an open lecture and this is not mentioned in the planning. To link this evolution to the evolution of amphibians, reptile, aves and mammals. SLO student will be able to understand and convey the concept of tetrapod evolution, and the next student will be able to understand the land adaptation and transition from the aquatic to terrestrial lifestyle. You have seen this figure numerously in past or in previous lecture. In this figure, evolution or the phylogenetic relationship is shown of ancestral deuterostome to the extant chordates or the higher chordates. You can see these are the kynoderms, these are the urochordates, cephalochordates, hagfish, lampreys and jaws vertebrates. When you say about the jaws vertebrate, mean they have a well-developed jaw in their body, and jaws vertebrate further lineage into different category or the different groups, where there come the craniates and further chordates. When you say about chordates, we have been studying throughout this course about the chordates. The first vertebrates on the land were the amphibians in the Devonian period. Devonian period is also the period which may be termed as the period of the fishes, and Devonian period was approximately 400 million years ago, and may have arose from the Rapidacean. Rapidaceans are the organisms which develop various type of structures which help these organisms to sustain their life on the land as well as in the water bodies. Arose in coastal and brackish marine water or marine environment. Here low fin fish is shown in the figure A, and in the figure B these are the early amphibians. Their load has been changed to limb, and their lobe developed various type of extra structure that was the requirement of that time, and they developed limb in their body. This is diagram for evolution of amphibian or the tetrapods with reference to the timeline from the Silurian to the Permian or to even to the present time. They have shown this evolution started from the ray finfish, further extended to low fin fish and to lungfishes. Lungfishes, we know that they are well adapted to survive on the land for a period without water. And after that, there were other type of the organism ending at the Ichthyostega and Acanthostega, and these were further changed or adapted to other organism or gave rise to other organism that were the Harnepton or further Grapton or further amphibians and latest amniotes. Typical tetrapod limb structure is shown with the sporting bone for the gills. Here you can see that they have also different type of bones like the limbs of other chordates have. Advantage of terrestriality mean if any organism is going to lead a life on the land, what are benefits and what may be pros and cons of this one or this behavior, like an increase in the metabolism and development due to the higher body temperature. An organism living in the water body as compared to living on terrestrial environment or in terrestrial environment have higher body temperature due to different type of environmentally driven factor like convection, radiation and evaporation and other type of biophysical mechanism. An increase of 10 degrees Celsius mean temperature from 20 degree to 30 degree would allow for a doubling of their metabolic rates. Mean their metabolic rate will be increased and it will cause the doubling of the metabolic rate, and definitely further it require energy and it also require good state of ventilation or gaseous exchange. Tetrapods generally, if they were to develop a life for land, they surely need something that was lungs. To breathe in air, it required an increased vascularization of the air field cavity, a pouch from the posterior pharynx similar to the swim bladder. Here we have learned about the swim bladder or the structure which help organism or the fishes in buoyancy with a rich capillary network to form a lung. Means swim bladder in few fishes or few organisms change into lung containing highly vascularized network of blood vessel for exchanging gases with the environment. Next, double circuit circulatory system. We know that the fishes generally have single circuit circulatory system, but tetrapod or the higher chordates have double circuit circulatory system. Fish have a single circuit circulatory system, mean low blood pressure, and the double circuit circulatory system allow for higher pressure, definitely with one circuit going to the lung and other to the body. Nasal opening in the bony fishes, there are 4 external nares or the nasal opening, 2 on each side. Here in the diagram you can see these are the nares, these are external nares, and these are 4 in number, and allow the water to run across the olfactory tissue where the message is generated and sent to the brain, and further smell or olfaction is detected or the message is detected. But in contrast to bony fishes or the fishes, tetrapod have 2 external and 2 internal nares in the palate. This allow air to be drawn in through the nose. Mean tetrapod have also 4 nares, but 4 are not the external. 2 are the external and 2 are the internal. Next, body density of the limb. Air is 1000 times less buoyant than water. Definitely, if any organism want to lead a life here on the terrestrial environment, surely first thing it need to counter the effect of gravity. And if it want to counter the effect of gravity, density of the limb should be higher. as compared to animal living life in the water bodies. Homologous structure are usually present in these organisms, and here bone in forelimb, humerus, ulna and radius and other type of the bones are usually seen throughout the chordates, starting from the amphibians to the higher chordates like mammals. In fishes, the pectoral girdle is attached to the skull. Here in the fishes, pectoral girdle is directly attached to the skull. In early tetrapod, develop a stronger shoulder girdle, bulky limb bones and well-developed muscles. The pelvic girdle is fused to the backbone to increase the force that can be generated by the hind limb. Here, the pelvic girdle is fused to the backbone. This is seen throughout the lineage of the chordates. Next, they develop vertebrates, and vertebrates develop zygapophyses. These are the articular processes which help for the attachment of different structures to the next one, or different bones to the next bone. These are the structures which help the attachment of different vertebrates with each others and further help to support the body. Development of the rib can also protect lungs. Definitely this was also an advancement. Body density, skull and neck. Skull have been shortened and the snout elongated. Here a diagram have been shown starting from the Asthenopteron to Ichthyostega. You can see that there are some adaptation in the skull, and further head becomes separated from the body by a neck, a cervical vertebrae that allow the head to be lifted. They added cervical vertebrae in the neck regions to allow the movement of the head region. A second vertebrae was then added to allow a side to side movement. Definitely we can move our head from one side to other and anywhere we want. This is the movement because there are two types, atlas and axis. There are two types of the special first vertebrae of the neck. Next, this is the diagram of fishapod. They also possess fish character. This is the diagram. These are the fossil record of fishapod that we have earlier said that these are the Tikalik and containing these characters of the fishes and these characters of the tetrapods. Here in the yellow box you can easily evaluate. Further, this is the explanation for the fishapod, a fish with the tetrapod feature. This animal probably could not walk on the land but could lift itself out of the water. And it was possessing fish-like characters, scale, fins, gills and lungs, and tetrapod-like characters, neck, ribs and fins, skeleton and flat skulls, eye on the top of the skulls. These were the amphibians-like characters, the tetrapod-like characters. And further from here we start the focus on our next chapter.